Hello all, Namaskar. So we have all heard of the word Operation Research, but do you know the history of this word? The term Operation Research was coined in 1940 in a small town of Budsway in England. It was during the World War II. The military management of UK called on scientists from various disciplines and organizations and arranged them in teams so that they can brainstorm of how the war decisions can be solved mathematically and find an optimal solution. No, so these teams were formed to find an optimal solution during World War II. So in decision, it is paramount to see, as we all know that in war decisions, it is paramount to see the movement of army, navy, and air force, their route planning, and providing of resources. So they use this operation research to find an optimal solution in this decision taking during the World War. Now, after World War, it was thought that this approach can also be applied in business scenario. So we got what is called operations research applied in logistics, supply chain management, the transportation problem. Now, it is the art of winning the war without actual fighting. So, we move on to understand the business concept of what is how operation research can be applied in business concepts so we can have more profits, which is paramount for any business operations. So, what is transportation problem? So, we need to understand what is transportation problem. Now, when we are doing business, there has to be the goods or the cargo has to be transported from one location to different destinations. So it is the transport of various commodities of a single homogeneous commodity to different destinations in such a way that the transportation cost is minimized. Because for any business operations to succeed, it is the margins. So in transportation problem, there are mainly three methods which are primarily used. One is the northwest corner method, second is the least cost method, third is the Vogel's approximation method. We will see how operation research tool is used to find optimal solution in the transportation problem through all these three methods. And there are two more methods which we will be discussing, which is the row minimum method and the column minimum method. Now, uh, see, we in transportation problem we do it through a matrix. So here we have got the origins, the source, and here we have got the destinations. So there are three source origins like O1, O2, O3, and there can be four or more destinations. Destination 1, destination 2, destination 3, and destination 4. So this is plotted in a matrix form where from within the matrix it is the cost which is mentioned, and then there is a column for supply and there is a column for demand. So from origin 1 to destination 1 the cost is 10, and the supply requirement from origin 1 can supply 15, and the destination 1 demand is 5. So we have put it in a matrix form. Here we can see that the if we make a total, the first step to uh, is to find the we need to check if this matrix is balanced or it is unbalanced. So first step is to check if the matrix is balanced or if it is unbalanced. Now in this matrix we can see that it is balanced between demand and supply. So the total of supply is 15 plus 25 plus 10, that is 50, and the total of demand is 5 plus 15 plus 15 plus 15, that is also 50. So this is a balanced transportation problem. If uh, it is a balanced transportation problem, then normally it is mentioned here as the total of the supply and total of the demand. If it is in case the transportation problem is unbalanced, then we need to add a row or column suitably. That we will discuss later on. Now, in case of the first method, the northwest corners method, uh, in this matrix, what we had to select? We have to select the first cell, which is the northwest cell. So northwest cell is O1 D1, which is 10 here. And then what we need to do further? We need to then bring the minimum of the supply or demand, whichever is lesser, inside the northwest corner and subtract from both demand and supply. We can see this as here. So let's start our learning, which is a happy learning. So we should have some fun also. So what we do is there, we have got a demand of 5. So we bring 5 inside the northwest cell, and we write it down here as 5. And uh, we also cancel the row or the column destination which has got 0. Now what we have done is we have we have brought the demand within the northwest cell, and after bringing the demand in the northwest cell, we subtract it from the demand and supply both. So here from we subtract 5 from 5, so it will be 0, and here we subtract from 15 minus 5, so it will be 10. So we mention it here as 10, we mention it here as 0, and when we bring in the minimum demand inside the cell, so we write it here, and we subsequently, as this demand has become 0, so we need to cancel uh, this whole column. And now what is the second step? Once we have done this, we move to the next northwest cell. So the next northwest cell in this matrix, the matrix is this. So we don't keep supply and demand, which is only mentioned here. So we cancel it here, and the northwest cell in this matrix is now this cell, which is 0, 2. So we move to the next cell, keeping uh, keeping the format as original, which was this. So we have already cancelled this column, and now what we do is we have moved to this cell. Now what we do, we of this supply is 10 and demand was 15, so we need to bring in the minimum. So we bring the minimum inside the cell, and we subtract it from both supply and demand. So we bring 10 inside, and we have subtracted 10 minus 10 is 0, and 10 15 minus 10 is 5. So we mention it here as 0, I mention it here as 5. And now since this supply has become 0. So we cross it this row in the matrix. Now our third step in the northwest method will be, we have seen we have cancelled this, and we have cancelled this column earlier, and we have cancelled this row in the second step. Now in the third step, again the northwest cell is this 07. So we had here 5 uh, demand which was balanced. The balance demand was 5. So we bring in the balance demand inside the northwest cell, and we subtract it from the demand as well as from the supply. So we will have 0 here, and we will have supply as 25 minus 10, 5, sorry, 25 minus 5, it will be 20. So we will have 0 and we will have 20. So now this cell is having, this column is having 0 demand. So we need to cross this column. In our fourth step, we again make this entire thing again here, and now our northwest cell will be this cell. So we bring in here it was 15. So and this was 20. Demand is 15, supply is 20. The minimum is 15. So we bring 15 inside the northwest cell, uh, subtracted from the demand as well as supply. So if we subtract from demand, it will be 0, and from supply it will be 20 minus 15 will be 5. So we will have here 15 inside the cell, and here it will be 0. Again we cross the column which is now having 0 as demand. Fifth step, we carry it over, and then we have already marked these as cancelled, and now in this the northwest, the balance in this the northwest cell is 20. So we select the cell with the 20, cost of 20, and then we bring the minimum of supply or demand. So minimum of supply or demand is 5. So we bring 5 inside, subtract it from the supply. So here it becomes 0, and when we subtract 5 from demand of 15, it becomes 10. So this will be 5 and 10. And now we have only one cell left, which is this as northwest cell. So in the next step, we will bring this also inside. So now we see that all the supplies and all the demands have become 0, and we have got some cells with allocation in origins and destination as well. So we make a chart of initial feasible solution. So our chart of initial feasible solution is like this. So here we have got origin, uh, and we have got demand, wherein now the supplies are 0 and the demand is also 0. Now here we need to make one check that m plus n minus 1 is equal to number of allocated cells. So here m is 3, n is 4. So m plus n is 7, minus 1 is equal to 6. So now we should have 6 allocated cells, which is 1, 2, 3, 4, 5 and 6. So this satisfies the m plus n, the formula m plus n minus 1. So we can see here the starting basic solution will be x11, that is x1 1, that is 5, x12, that is 10, then x22, that is 5, then x2 and x3, that is 15, then x2 and x4, that is x24, that is 5, and then x3 and x4. So x34 will be 10. So the starting basic solution is given as uh, x115, x12 10, x225, x23 15, x24 5, and x34 is equal to 10. Now the objective function value, to work out the objective function value as per the OR will be Z is equal to, this will be the starting solution value into the cost, that is 10. So 5 into 10, then 2 or 10 into 2, then 5 into 7, then 15 into 9, 5 into 20, and 10 into 18. Now if we get the solution, so it will be 50 plus 20 plus 35 plus 135 plus 100 plus 180, which is equal to 520. So Z, the objective function value is 520. Now we can convert it into currency value, say INR 520 or dollar 520. So we see that in the northwest corner method is used when it is the purpose of completing the demand in number one, and then the next, and used when the purpose of completing the warehouse number one and then the next. So we are been selecting that in the matrix the northwest cell to solve this uh, transport problem by northwest method. Hope this is clear to all of you now. Now our second uh, method is the least count method or the minimum cost method. Now in as we are using the same matrix to show the different types of solutions we can get in the transport problem. So in this method, we will follow all the steps which as we followed in the northwest method, only our selection start at minimum value cell in the matrix. So in the whole matrix of origin and destination, we have to see which cell has got the minimum value or minimum cost. So here we see in this matrix our minimum cost is 0 2. So we start with this cell. Here in this cell we see the demand is 15 and even the supply is 15. So we bring at random any value of 15 inside the cell, and when we subtract from demand as well as supply, so we will get 0 and 0 here. So we will cross this cell and this row. Okay, we as you see we have crossed this cell and this row, and then what we will see, we will have to find the next minimum uh, value. So next minimum value will be 0.4. So when it is 0.4, the next minimum value, so what we do is we bring in 5 inside, minus 5, and from the supply also we subtract 5. So it will be 5 here also. So we have got 5 here and 0 here. So we cancel then the cell or column D1. So we have cancelled D1 and we have cancelled this row. Then we have got in the matrix 9. So again we bring the minimum of demand and supply, which is here it was 25, here was 15. So we bring in 15 inside. Now when we bring in 15 inside, here it will be 10 which is left, and 15 is then 0. So this will get cancelled here. Now, then what we will be left? We will be left with these two values, that is 18 and 20. So 18 is minimum. So in 18 and minimum, we were here, it was balanced as 5, which was not crossed. So we bring in 5 inside and we subtract from 15 minus 5, that is 10. So we will have 10 and here it will be 0. So here it will be 10 left and here 10 left and here that it is the last cell. So we bring in 10 inside and then we have got the whole cell solved. So we draw a initial feasible solution. Now in the initial feasible solution, here we have got it. Oh, 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 oh. Oh. Check if satisfy. If m plus n minus 1, that is matrix add of rows and numbers, subtract 1, it should be equal to allocated cell. So 3 plus 4 minus 1 should be 6. But we find that the allocated cell in above initial feasible solution is only 5. As such, this is not the correct solution. So we have missed something. What is it? Okay, let's try to correct it. So, where had we gone wrong? Okay, so we had selected here 2, got 15 and 15, 0. Okay, but here we have to make sure that we select only either the row or the column. So I have taken as row as my selection. Okay, so we have to ensure that only one, either row or either column is selected for cancellation. Once we do that, then we move to the next minimum cell, which is 4. We bring in 5, we deduct from 10 5, so it will be 5 left, so we cancel here 0 and then we cross this cell. Okay, now we move to next, which will be 9. So from 9 it will 15 will come inside, so minus 15, it will be 10. So we will be left with this 10, we will be left with this 5 and then we will cancel this row also. So this we have not cancelled, but here we have got 0. So next one will be our, which will be the minimum cell. It will be 11. So what we need to do is we say we need to select this, bring 0 inside and then we cancel this entire row. Okay. So we had missed this step in the last uh, uh, solution. And when we move forward, we then select 18, bring the 5 in. So we will have 10 here and 10 here. So next step, we will be left with this 20. So we bring this 10 and we bring this 10 inside. So we will have 0, 0. So all our supply is satisfied as 0 and demand satisfied as 0. So we will have now this initial feasible solution, which is given. So m plus n minus 1 is equal to 3 plus 4 minus 1, that is equal to 6. And here allocated cell, that is 1, 2, 3, 4, 5 and 6. So we have got the number of allocated cells as right as 6. So the starting solution will be x1 into x2, that is 15, x1 x4, that is 0, x2 x3, that is 15, x2 x4, that is 10, x3 x1 x3 3 1, that is 5, x3 4, x3 x4, that is 5. So the starting solution is x12 15, x140, x23 15, x24 10, x31 15 and x34 5. Now the objective function value will be z is equal to 15 into 2 plus 0 into 11 plus 15 into 9 plus 10 into 20 plus 5 into 4 plus 5 into 18. So that is 30 plus 0 plus 135 plus 200 plus 20 plus 90. That is 475. Say INR 475 or dollar 475. So we find that in least count method, uh, it's a better solution by concentrating on the cheapest route, as it yields a smaller value of objective function value, which is 475, whereas compared to 520 in northwest corner method. So here the objective function value will be lesser than the northwest corner method. Clear? Now we move to the third methodology, which is which will give a more optimal solution, which is known as Vogel approximation method. Now, in case of a Vogel approximation method, for each row and column, we need to determine a penalty measure. Now, how penalty measure is determined? It is determined by subtracting the smallest unit cost element in the row or the column from the next smallest unit cost in the same row or column. So we need to measure the penalty of each row and column in the matrix. How we will do that? Just let's see it. So we redraw the matrix, leaving some space on the right and on the bottom side. So in this row, if we see this row, we draw a line here and we draw a line here, and when we work out the penalty, row penalty, and then we have to work out the column penalty. Now the row penalty, how to work out the row penalty? In the row, see which is the minimum value or the minimum cost and which is the second minimum cost. So the minimum cost here is 0.2 and the second minimum cost is 10. So the penalty for this row will be 8. Okay. Now we move to second row. In the second row, we see that this value is 0.7. The minimum value is 0.7 and the next minimum value is 0.9. So here the penalty will be 0.9 minus 0.7, that is 2. Similarly in row 3, the minimum value is 4 and the next minimum value is 14. So the penalty here is 10. Now we work out the penalty for columns. So here we have 4 and 10. So 10 minus 4 will be 6. In the second column, the minimum value is 2 and the next minimum value is 7. So if we subtract 2 from 7, it will be 5. Then in the next column, we have got minimum value is 9 and next minimum value is 16. So 16 minus 9 will give me 7. In the next column, we have got the minimum value as 11 and next minimum value as 18. So 18 minus 11 will give me 7. So now we have got the penalty. It is 6, 5, 7, 7 in the column, and in the row it is 8, 2, 10. So we need to select the highest penalty. So in the highest penalty it is 10. So we mark it with an arrow up. So it is the highest penalty, and when we solve this matrix for this row which is having the highest penalty. So we adjust the demand and supply by bringing the minimum of demand or supply. Here the demand is 5 and here the supply was 10. So what we do is we bring the demand of 5 inside this cell of minimum in the row of the highest penalty, which is 5, and when we subtract it from both demand as well as supply, so demand will become 0 and supply will become 5. Got it? So identify the row or the column with the highest penalty, break ties arbitrarily, allocate as much as possible to the variable with the least unit cost in the selected row or the column, adjust the supply and demand and cross out the satisfied row or column. Know if the row and column are satisfied simultaneously, only one of the two is crossed out and the remaining row and or column is assigned zero supply demand. Clear? So we need move to the next step. We draw the same matrix again, and we are on second step. Now in the second step, uh, this row was this column has now become 0, so we cross it. We carry over the same quantities, mark the same quantities, and then we again work out the penalty, which is known as P2. So now here it will be in the first row if we go, so it will be 0 to the minimum value and 11 the second minimum value. So we subtract 2 from 11, so we get 9. In the second row we have got the minimum value as 7 and second minimum value as 9, so we subtract 7 from 9, so we get 2. In the third row we have got a minimum value as 14 and next minimum value as 16, so we subtract 14 from 16, we get 2. For column, we have 7 and 14. The first one will be 0, nothing, there will be nothing because it's already cancelled off. And in the second one, it will be between 0.2 and 0.7. So it will be 5 here, 5. In the third column, it will be 9 and 16, again 7. And in the third column, it will be 11 and 18, again 7. So we have got the column penalty and we have got the row penalty. In both of, when we observe, we find that 9 is the highest penalty. So the we need to solve for the highest penalty 9. We need to find the minimum value. So the minimum value here, which is of the matrix, will be 0.2. So we of this cell 0.2, we find that the demand is 15 as well as the supply is 15. So we bring in 15 inside the cell, and we subtract from both demand and supply. So 15 minus 15 is 0, and here also 15 minus 15 is 0. But one thing we need to remember, we need to cross only one, uh, either the row or either the column which has having now the demand and supply as 0. So we have got both here. The demand is also 0, demand is 0, and supply is now 0. But we need to cancel only one. So we have chosen, it is your choice. So we have chosen this to cancel as 0. Now we had this as 0. So we had this 0. So now we move to third penalty. Now the third penalty, how we have drawn? We have drawn the third penalty. This call has already become 0. So we here there will be no penalty, and here there will be no penalty. So here the row penalty will be 7 minus 9, that is 2. 14 minus 16, that is also 2. And here it will be in the column it will be 7 minus 14, so it will be 7. And 9 minus 16, so again 7. And 20 minus 18, so it will be 2. So in this highest penalty is 7. So we take this column for solution, we bring in the minimum value inside. So minimum value already it was 0. So we bring in 0 inside here, and we need to subtract it from the row also, supply also. So we subtract it, but there will be no change. So it will remain as 25. Okay. Getting the point now? Okay. Good. You just need to, it is very simple. Basically, you just have to follow the principle, and then we just keep crossing and finding the solutions. So we have got here, we have got two columns cancelled and one row cancelled. Now we need to work out again the penalty 4. So this was cancelled and this row was cancelled. So these two are cancelled and this is cancelled. So we mark them as there is no requirement of calculating the penalty. So we will be calculating the penalty here. So the penalty here will be the difference between 9 and 20. The minimum value and the next minimum value, which is 11. And similarly here it will be 2. So here it is here 2. And this will be 9 and 16. So 7 and 2. So again we see the highest penalty here, it is 11. So we need to solve the row having the highest penalty. So we will be solving this row. So what we do is we bring in the minimum of demand or supply. So here it is the minimum is 15. So we bring in the demand of 15 inside the cell, and we subtract it both from demand as well as supply. So here we will subtract it from demand and supply. So here we will get 0, and here we got 25 minus uh, 15, which is 10. So we are left with this. So we move to the now we have done 4 penalties. So we move to the next step here. Now it is basically 2 rows and 3 columns which are not satisfied. So in the penalty 5 we have got 3 rows which are satisfied and 2 columns, one column which is satisfied, one row which is satisfied. So we will have 20 here. So we bring the penalty here will be 20, the penalty here will be 18, and the penalty here will be 2. So highest penalty is 20. So highest penalty is 20. So we solve for this row. So we bring the supply, which is 10, inside the cell, and we subtract it from the supply, it will be 0. And when we subtract it from the demand, it will be 5. So we will have 10 here and 5. And lastly, what is left with us is the 10, 18. Only one column is left, and we solve it with penalty 6. So it will be 15, and uh, basically this penalty we have to bring here. Now we see that m plus n minus 1 is equal to 3 plus 4 minus 1, that is 6. That is number of allocated cells. So we draw our initial feasible solution. Our initial feasible solution, after we have now, there is a lot of confusion or many things have been crossed here. So we draw a fresh matrix with the initial feasible solution. So it will be like this. So we have got 10, 0, 15 and 0, 5, 15 here. So the starting basic solution is given as x1, 2, which is 15, x 2, 2, which is 0, x2, 3, which is 15, x2, 4, which is 10, x3, 1, which is equal to 5, and x3, 4, which is equal to again 5. So now we calculate the objective function value, which is 2 into 15, 7 into 0, 9 into 15, 20 into 10, 4 into 5, and 18 into 5. So we have got 30, 0, 135, 200, 20, and 90. So it can be as 475. This is 475, so 475. So we find that in case of Vogel's uh, approximation method, the VAM, or what we call as VAM, it produces a better starting solution. So we have got a value of 475, whereas in north west corner method it was coming as 520. Clear? So we have covered the main three methods which are normally used, and WEM or Vogel's approximation methods give you the most near to optimal solution. Now we will also look into another method which is called the row minimum method to solve the transportation problem. So we draw our same matrix again. We have got 3 origins and 4 destinations. The cost from each origin to destination is given in this cell. It is a cost cell. These are the cost from origin to destination. And from origin 1 we can make 15 truck supply. From origin 2 we can make 25 truck supply. From origin 3 we can make 10 truck supply. And when we see the demand, so destination 1 needs 5 trucks, destination 2 needs 15 trucks, destination 3 needs 15 trucks, and destination 4 needs 15 trucks. So when we make the total of supply and demand, we find that the supply and demand is matching. So 15 plus 25 plus 10 gives you 50, and demand is also 5 plus 15 plus 15 plus 15, which is 50. So it is mentioned. If there is a, this is a balanced transport problem, and if it is a balanced transport problem, the total will be mentioned here, but it is always better to cross check, uh, uh, because if there is any error in calculations, your all efforts to make calculations will be wasted. Now in case of a row minimum method, what we see is that the row minimum method start with the first row. Mm. As in northwest corner method, we had started with the northwest corner cell. Then in minimum cost method or the least cost method, we have selected the least cost of the entire matrix, which was 0 2 here, like this 0 2. So we select the least cost cell. And in case of Vogel approximation method, we calculate the penalty of each row and each column, and then we select the highest penalty, and then we solve the row or the column for the highest penalty. But in case of a row minimum method, we need to start with the first row itself, that is the first origin itself, and we choose the lowest cell of the first row, so that either the capacity of the first supply is exhausted or the demand of jth distribution center is satisfied, or both. So here in the first row we see uh, which is the minimum cost or minimum value. It is 0 2. So we will select this column which is 0 2, and we start solving it that way. So we have selected 0 2. Here the demand supply is 15 as well as the demand is 15. So what we do is we bring in the minimum of the demand or the supply inside the cell. So we have brought 15 inside to the cell, and we have subtracted it from both supply as well as demand. So here it will be 0 and here it will be 0. 15 minus 15, 0. 15 minus 15, 0. Now we have to randomly select for crossing either the row or the column, which is ever 0. So I have randomly selected row to be cancelled. Now in the second step, we move to the second row. We have to select the second row and we have to select the minimum cell of the second row. So the minimum cell of the second row is 0 7. So we have selected 7, and here the supply was already, demand was already 0 and the supply was 25. So we need to bring in the demand, which is the minimum of the demand or the supply inside. So because we have to work out the minimum cost now, so we have to bring minimum inside. So we bring 0 inside and we subtract from both the demand and the supply. So here it will be remain as 0 and here it will remain as 25. Same, it is copied here, and then we move to the third row. In the third row, minimum is 4. So we need to bring in 5 inside here, and we need to cross it then. So and so forth. We move forward and we keep working it like this. First the row, so the initial feasible solution workout here is, as you can see, is where we find is 1 2 3 4 5 6 cells. So we have got to find 3 plus 4 minus 1 is equal to C. So the number of allocated cells match. So the starting basic solution is given as this, and the associated objective function is work out to be 505. Hence we find the cost is less than the northwest corner method. Clear? Now we move to our last uh, method, which is the column minimum method. Now as we see in the row minimum method, we started from first row to second row till it is exhausted, to 0. So similarly, we move in the column minimum method till the columns get exhausted to 0. So first step will be to satisfy this column as 0. So the first column, the minimum value is here is 4. So we have taken 5 inside, deducted 5. So this is column has become 0. In the second step, we find that 2 is here minimum. So we move it again to 0. So this column is satisfied. Then in the third step, we have got 9 as minimum. So we mean when we move, so this is also getting exhausted in the first step itself. So it will be 0 here, and we have got moved a 15. And in the fourth step, since this is 15 balance, so here the minimum value is 11 or 18 here. So we move 15 to 18 because this is already cancelled here, 15 to 18, and then we solve it here, and accordingly our initial feasible solution is here. So the starting basic given value is x12 is 15, x23 is 15, x24 is 10, x31 is 5, x34 is 5, and objective function value in this case also it comes as 475. Now this column method is used when we want to satisfy the demand for first location. It is important. And now if we want to satisfy the demand of first location, then we move on to second location, then the third location, then the column minimum method is used. But if we want to satisfy the supply of first location, then the supply of second location, uh, then the supply of third location, then the row minimum method is used. So uh, if we want to satisfy the demands first, then the column minimum method is used. But if we want to satisfy the supply first, then the row minimum method is used. uh, it is basically depending on what is our urgency or how we want to satisfy the demand. I hope you have liked and understood the concept of this entire operation research transportation problem, uh, which is a very good tool. It is a strategic logistic tool for finding the minimum cost and the best solution, uh, how to satisfy the demand and uh, supply. I hope you have liked this, and this is being used in logistic supply chain management. Uh, Please subscribe to my channel for further informative and learning videos. Thank you so much. Please like and share this video. Thank you.